go. So today we're going to solve exponential equations. So yesterday we graphed exponential equation, and pretty much anytime you have an algebra class, at some point you're going to solve. So we're going to solve exponential equations. Well, how do you solve an exponential equation? Right? Now, there are ways to use a calculator, which we're going to learn about next week. But today, we're going to solve without a calculator. And we're going to start off with something really basic. Right? So if I give you 2 to the x plus 1 is equal to 2 to the third, right? This is an example of an exponential equation, right? Because there is a variable in the exponent, right? Now, everything that we're going to do today hinges on when you look, everything we do today is kind of simplified down to something that looks like this. And if you look at this equation, notice how this 2 equals this 2. And if this 2 equals this 2, that means this exponent has to equal this exponent. And so we end up with x plus 1 is equal to 3, and we end up with x equals 2. And we have now solved an exponential equation. Does that make sense? Right? Right? No, I mean, that's the big idea. The big idea is, if you see 2 to stuff equals 2 to stuff, then you can say, oh, stuff equals stuff. Right? And then solve. All right? Of course, they're not always going to look like that. You know, another way this problem could have been given to you is I could say, well, what's 2 to the x plus 1 is equal to 8? Right? Now, how do we solve this? Well, your first response is, well, it doesn't look like this. But then you say, well, can you make it look like this? Right? Remember, the only way you can solve it is if the bases are the same. And so we need to do something with 8. Well, how could we rewrite 8? 2 cubed. Oh, so it ends up being the same problem. Everybody see how that worked? All right? Now, in practice, they're not always going to be this easy. Actually, I don't think they're ever going to be this easy. Right? Typically, they look like this. What if I give you 4 to the x minus 2 is equal to 8 to the x plus 4? This is a little more realistic about the types of problems I want to make you do. Right? And so when you look at this, you're right, remember, your goal is you want them to both have the same base. Right? And you might look at this and say, well, I really can't make 4 to what power? Actually, time out. Let me go back and talk about another trick. Before we start this, are we okay that if I gave you 2 squared cubed, that gives us 2 to the 6? Anytime you have an exponent raised to an exponent, you multiply them? Meaning, if I have 2 squared to the x minus 4, this is going to be the exact same thing as 2 to the 2x minus 4, where anytime you have an exponent raised to an exponent, those get multiplied. All right? All right, so now I look at this problem, and I was like, I need the bases the same. Right? That's what you need. Every problem that I give you today, you need the bases the same. So what do? Well, first you have to think, well, what's the common base? 2, right? All right, can everybody see your common base is 2? Can I rewrite 4 as 2 to some power? Can I rewrite 8 as 2 to some power? Right? That's your common base. So how am I going to rewrite 4? 2 squared, right? So this is going to give us 2 squared. And then I still have that x minus 2. And then this is going to be 2 cubed. And I see the x plus 4. Everybody see what we've done so far? And remember, our goal is to get to that one stage where I have 2 to stuff equals 2 to stuff, so I can just write the equation. And so when I look at this, okay, anytime I have an exponent raised to an exponent, I get to multiply, so this is going to give us 2. And that's going to give me 2 times x minus 2 is equal to 2 to 3 times x plus 4. And now do you see we have our simple algebra 1 equation? Right? I have 2 to stuff equals 2 to stuff. And so now I can say stuff equals stuff. So I'll go ahead and distribute this. That gives us 2x minus 4 is equal to 3x plus 12. And now this isn't such a bad problem. Subtract to get an x, subtract to get a negative 16. Does that make sense? Okay, your turn. If I give you 9 to the x plus 1 is equal to 27 to the 2x minus 3, all right, what's your common base? 3. Everybody say our common base is 3? All right, now solve it. All right, so I look at this, and 9 is the same thing as 3 squared to the x plus 1, and this is 3 cubed to the 2x minus 3. Can I skip a step and say this is 2x plus 2 is equal to 6x minus 9? Is everybody okay with that step? Because these are the same, then that means these are going to be the same. And so it's going to give me 4x is equal to 11, and so I end up with 11 over 4 is equal to x. Did I do that right? All right. All right. Everybody kind of see how this works. All right. Everything hinges on you sort of identifying what's your common base. All right. Well, how do we make these things uglier? Because that's what's going to happen, right? You know, they don't always stay this way. What if I gave you 4 to the x plus 1 times 2 to the 4x minus 3 is equal to 8 to the x minus 5. You know, a little harder, right? Well, sort of. It's kind of the same thing. The first thing you have to ask yourself, well, let's make sure let's review our properties of exponents. As far as our properties of exponents, are we okay that if I gave you 2 to the 4th times 2 to the 5th, that's going to give us 2 to the what? 9. What did you do? You added. Are we okay? When the bases are the same, we can just add the exponents. Notice I said when the bases are the same. So I need a common base. What's my common base? You're okay, our common base is 2. So if my common base is 2, I'm going to rewrite everything as 2 to some power. So let's see. I'm going to rewrite the 4 as 2 squared to the x plus 1. And I got times 2 to the 4x minus 3 equals. And then the 8 I'm going to write as 2 cubed to the x minus 5. So far, so good? And I'll do a little more work here. So this is going to give me 2 to the 2x plus 2 times 2 to the 4x minus 3 is equal to 2 to the 3x minus 15. Are we okay with what I've got so far? I got everything to a base of 2. Great. I'm still not done because I need to have 2 to some power equals 2 to some power. I can't have this, I can't have 2 2's. But if the bases are the same, what can we do with the exponents? We can add the exponents. And so when I add the exponents, this is going to give me 2 to the 6x minus 1 is equal to 2 to the 3x minus 15. Did everybody see how I got here? I'm just adding those. Well, now this looks just like all the other problems. These are the same, so I can set these equal to each other. And then it's just a pretty basic algebra problem. My pretty basic algebra problem is 6x minus 1 is equal to 3x minus 15. So I end up with 3x equals negative 14. X equals negative 14 over 3. Hopefully I did that right. Does that make sense? All right. Well, your turn. Yeah, I need to. So let's have you do 9 to the 3x plus 4 times 27 to the x plus 2 equals 81 to the x minus 4. the left. Sorry about that. What's your common base? Is everybody okay? 3? Let's just make sure we all know the parts. 9 we're going to write as what? 3 squared. 27 we're going to write as 3 cubed. 81 we're going to write as 3 to the 4th. 3 to the 4th, you ask? Oh, isn't 3 to the 4th the same thing as 3 squared times 3 squared? Is 3 to the 4th the same thing as 3 squared times 3 squared? And 9 times 9, 81? 3 to the 4th is 81. Okay. Okay, so let's see, that's 3 squared to the 3x plus 4 times 3 cubed to the x plus 2 is equal to 3 to the 4th times x minus 4. So this is going to give me 3 to the 6x plus 8 times 3 to the 3x plus 6 is equal to 3 to the 4x minus 16. Then I get one big 3, and so that's going to give us 9x plus 14 is equal to 3 to the 4x minus 16. Now I've got the bases the same, so let's see, that's 9x plus 14 is equal to 4x minus 16. Wow. Did y'all get that? Yeah. Why did I say wow? I just made this up. I mean, I just random put stuff there. You know how hard, you know the chances of having a nice answer with just random stuff on the board? Yeah. That's not bad for just making stuff up. Yeah. It's not like I planned that. You saw what I planned. Like the previous examples that had weird fractions, that's what normally happens. All right, how do we feel about this so far? Okay, not too bad, right? Okay. Oh, well. So if I give you 2 to the 6th over 2 to the 4th, that gives us 2. 2 what? Squared. Where'd you get it? How'd you do that? Subtract. You subtracted, right? Everybody okay with that? So anytime you divide, you subtract. So what if I have 9 to the 3x plus 4 over 27 to the x plus 2 is equal to 81 to the x minus 4? Well, what's the first thing you're going to do?
Get the same bases.
Get all the same bases, right? That makes sense? So we already know what the bases are going to be. We know the bases are going to be 3, so this is going to be 3 squared to 3x plus 4, 3 cubed to the x plus 2 equals 3 to the 4th times x minus 4. Is everybody okay with that part? Right? Not a whole lot's changed so far. All right, so now this is 3 to the 6x plus 8 over 3 to the 3x plus 6 equal 3 to the 4x minus 16. And guess what we're going to do here? Subtract the exponents, right? Remember, the way we solve this is I need, effectively 3 to some power on this side and 3 to some power on this side. So if I subtract those, this you got to be a little careful about. This is 3 to the, let's do 6x plus 8 minus 3x plus 6. Make sure that's in parentheses, equals 3 to the 4x minus 16. You see how that worked? I'm subtracting the exponents. Yeah, sorry. Those books don't really do a good job as a window. And so now I end up with, let's see, I can just drop those. So 6x minus 3x is 3x. 8 minus 6 is 2, is equal to 4x minus 16. And so end up with an x is equal to 18. Does that make sense? I mean, it's the same thing, right? Everything hinges on 3 to some power equals 3 to some power. All right? Well, what if I gave you 1/2 to the 3x minus 4 is equal to 4 to the x plus 1. What's your common base? Still 2, isn't it? Like this, we look at and we say, okay, this is not so bad. I write this. This is going to give us 2 squared to the x plus 1. But what's this going to be?
2 to the negative
1. Do you see how this is 2 to the negative 1? Isn't 1/2 2 to the negative 1? So I could rewrite this as 2 to the negative 1 times 3x minus 4. And now, do you see I have kind of the same situation? Now I have this is 2 to the minus 3x plus 4 is equal to 2 to the 2x plus 2. That would have 2 to stuff equals 2 to stuff. And so now I can set these things equal to each other, so I get minus 3x plus 4 is equal to 2x plus 2. If I add those over, that's going to give me 5x is equal to 2. So I end up with 2 over 5 is equal to x. No, because you got to get the x by itself. Are we okay with this? So when you see a fraction, right, you can flip it, right? And it makes a negative. All right, how do we with this? All right. So what if I gave you 3 times 4 to the 3x minus 2 is equal to 24? Sorry. What would you do? What's the first thing you do? What? Divide by 3. I mean, you could look at this and say, well, 24 isn't anything to a power, right? Notice how all the other numbers I gave you, those were like something squared, something cubed, something to the 4th. 24 isn't any of that, right? Like, you're stuck. You have no clue how to do it. But you got that stupid 3, right? All right, so we divide both sides by 3. All right. So I end up with 4. 3x minus 2 is equal to 8. Now, does this look like something you could handle? Okay, so finish. Are these getting easier? Hopefully not as scary now as the first time you saw it. The benefits of, taking individual steps. All right, so what's our common base? 2, right? I need to be a little more creative. I think everything I've done has been base 2. Handful of base 3s. Right? So this is 2 squared to the 3x minus 2 is equal to 2 cubed. So end up with 6x minus 4 is equal to 3. And can I go ahead and say that's just 7 over 6? All right. everybody okay with that? Well, what if I gave you 2/3 of the 4x minus 1 is equal to 9/4 the x plus 2? Just throwing some random stuff out there, right? What's your common base? No.
2/3.
2/3. That's 9/4. Does 9/4 have anything to do with a 3 and a 2?
It's flipped and squared.
Do you see that that's 9 is like a 3 squared, that 4 is a 2 squared? Do you see that this is the exact same thing as 2/3 to the negative 2?
Yeah.
Do you see it now? Okay, well now you know to look for it. Well, no, what are the clues, right? Do you see the clues in the problem? There's a 3 and there's a 9. There's a 2 and there's a 4. Do you see that as a clue, right? Do you see they're squaring something? Well, because they're squaring something, right? So this is that thing squared, but it's also flipped, so it's a negative 2. So this ends up being 2/3 to the negative 2, all raised to the x minus 2.
Plus 2.
Plus, thank you. Are we okay with that? And so now I have 2/3 to the 4x minus 1 is equal to 2/3 to the negative 2x minus 4. We okay? The bases are the same, so now it's just an algebra problem. I can say 4x minus 1 is equal to negative 2x minus 4 and solve. Put this over here, I'm going to end up with a 6x. Move this over here, I end up with a negative 3. And so x equals negative 1/2. Does that make sense? Much better than